Hello everyone. Assalamualaikum warahmatullahi wabarakatuh. My name is Iwan Setiawan. I come from Purwokerto, Indonesia. You can see on the map. It is 500 kilometers from Surabaya, I think. Yeah, 9 to 10 hour travel time. So I'm a teaching staff at Department of Electrical Engineering, Universitas Jenderal Sudirman. And I'm currently interested in system and networking, and I have a little bit experience in researching in computing, and particularly in classroom computing. So my interest is about the infrastructure, not the code. So I don't have any skills that have deal with programming. So I'm learning networking, and I've been relearning networking and try to catch up the advantages of the networking, particularly the software-defined networking. And for your information, I'm a system administrator. I'm more of system administrator and networking administrator, and I try to learn Python. So I'm no programmer. I think that will define me as a system administrator and no programming skill or have a little about the programming. So we have a software-defined networking. I've been learning this new technology, but it is not really new technology, because if we see the technologies around us, it is not really new. It is just some mix up from some technology and try to integrate to a solution. We can see here it is a Gartner Hype Cycle for Network and Communications. We can see that it is software-defined networks here. It is in 2015, and the prediction is about 5 to 10 years to go to the plateau of productivity. So if technology that pass the valley or the solution of slope of the graph, it will be productive, and it will be used actually in the in the world. Yes. You can see here Richpedia. It is already happened. Void over VLAN, yes. Hybrid 1, 802, 11AC, yes. So the trends on SDN is about I list two trends here. Gartner's Hype Cycle at AT&T has a plan to migrate its network to SDN by 75%, I think, in 2020. And many organizations have been using SDN in their network for research and operations. I particularly happen to know the configurations and the experiments of one of the telco operator in Indonesia. They experiment on this technology. So to put in context, we have SDN, and we have some environment that can build or integrate to one system. This is a Nokia Smart City building blocks. We have SDN in the middle, on the top of the infrastructure, IoT, and some physical layers, if you know the networking. So I'll try to make relation with this PyCon. So I change the software to the Python, and it is not deliberately. I'm not deliberately doing this for something, but I try to relate to the Python. So the first one you can see on the map, it is network, internetworks. We have many end system and hosts that connected to the network via the network devices, and there is also the refrigerator and traffic light, also what is that, temperature, yeah, sensor. And we can see on the image in front of you, we have a network device. And I just focus to this device. It is a router. And it is about, have two planes, actually. We have routers, we have two planes. The first is data plane, the second is control plane. So the first one, it is about the forwarding table, and the second one, it is about routing algorithm. Data plane is about forwarding switch between, if packet come from one interface, it can forward to another interface or another port. So we have two planes in networking. We have data plane that deal with forwarding elements. It is about forwarding elements. It is simple. It is hardware-based, frame switching. And on the top of the data plane, we have control plane. It is a logic control algorithm. It is like the brain of the data plane or the hardware. So the data plane just do some switching with some hardware-based frame switching like ASIC. And the control plane try to compute how this packet go to one side to another side. Yes. So these two planes, traditionally, if we have router in traditional network, it is coupled in the one network devices or network devices. So we have these two planes here in the every routers, and we have management plane on the top of the control plane. So we have remote access. Maybe you know some SSH or anything like that. And we have network engineer that manage the control plane to configure how these routers deal with the packets that receive and how to forward the packet. It is also, we have also other network engineers and also users configure the network, and this makes some difficulties in the network management. So I think if we compare with application programmer or application developer, my students, actually, I don't know, I don't ask specific student, but I think they don't want to deal with networking things because of the complexity, I think. Yeah. And with the SDN, I think this networking could be programmed with some expression. So the issues of the traditional networks is about network management, like in the pictures before here in front of you, network management. So we need to abstract the complexities of the network. Then after the abstraction, we have an open interface to bridge between the layer of abstraction and the second, flexibility. We have issue in flexibility. If we have some demands of maybe high data or video streaming, the network should be reconfigure itself to give some bandwidth to users that access the multimedia. Maybe some attacks, the network should defend themselves, fault, and other things. And the third one is about programmability. How the networks could innovate, innovate. If we have the computer system, we have applications, so many applications. This application is about innovation. How a programmer, developer try to innovate with solutions that can give user more give more things, give more value on their life. Yes. So this is the three issues in the traditional network. So we have traditional networking here, and we try to, the SDN try to move the brain of the in the control plane, the brain to the server here. So the brain in the network device put on on the server. So the switch, so the routers is not the routers, but the routers will be simple switch, forwarding switch. So in the switch it will have an agent. It is just an agent, and we have server there, and we have so many controllers to manage the network. It is just like to program the network. How to program the network, so it is more like computer system, yes. If we compare these traditional networks with SDN, we can see here traditional networks, and we have SDN. The control plane is not coupled with the data plane, but we have southbound API, some communication protocols, and we have northbound API that deal with management plane. And we have network engineer that config the SDN controller to program the network. So if we see the management plane also have application plane also. Yes. The management plane is the same with management. Management plane is the same with application plane. You can see on the picture we have computer system and SDN with different layers, 3 layers. We have hardware in computer system. We have also in SDN data plane. We have ISA, Faucet Architecture. We have southbound API, control plane, API, and so SDN is about abstraction and how we separate control and data planes. Data plane, simple forwarding elements, then control planes, controller, and there is a communication between those planes. And and on the top of the control plane, we have application plane that you, programmer, developer, can program application on the top of the controller. So if we have Python-based controller, you can write network applications on the top of the controller. So this application can be anything. It can be routing, mobility, a firewall, intrusion detection system, and other things. And it forces policies to the control plane via the northbound API. So we have some networks, and it deals with the complexities of the network, and we have some types of networks. And if you try to find the solution, you should choose one of these networks. And regarding the experimenting the SDN, we have 2 things, and I particularly try to do this, and I've been learning this by experimenting SDN in simulation. And if you have the hardware, you can build the testbed with real SDN switches. So I'll try to explain the data plane, but we have you can read on on the slide in front of you, there's a hardware switch which is from vendors, and there is also a board called Zodiac FX for SDN experiment on your desk. It is just small board like Raspberry Pi, and it has 4 or 5 ports, and you can experiment with it. Also, there is a chip switch that is usually used for the SDN experiment, particularly Zeppelin VR1040ND. It is flashed with OpenWRT to get the open flow protocol applied. And the software switch, it can be used in your computer and for the simulation. So we have the SDN controller, a middle layer, and there's a difference with the controllers. Controller, it is about the controlling it, and network operating system is more complete. And we have some basic core service that usually on the controller. The first one is topology discovery. It is about how to discover the switches, the interconnected switch, and the unconnected switch. And the host tracking is about discover the host and the inventory about how the networks, the data of the network, the information of the network, and the statistics it describes itself. So we have POPs in SDN controller. Voices and cloud written in Python 2.7. It supports OpenFlow 1.0 with OpenVSwitch and Sira extension. It is popular for learning SDN. If you have interest in this SDN, you can learn from POPs. You just need to put up with pops.py and just load components that built in or collected or have in the package of the POPs. So POPs also have Python APIs. Okay, you can start to write application with POPs Python API on the top of the POPs. The second one is Ryu. It is a component-based SDN framework. It is controller plus, include components, and it supports many versions of OpenFlow protocol. And it can be integrated with OpenStack. And it is used as the base SDN controller or framework by several projects such as Flow and Faucet. And we compare the controllers. I just take this from Nick Pemster. There is Nox, Pops, Ryu, Flatlight, ODL, Onos, and many other controllers. We have Pops and Ryu used in Python, and if we have the learning curve, it is easy to moderate. If we compare to Flatlight and ODL, the learning curve is really easy. Okay, running SDN in network emulator, we have Mininet. If you want to experimenting SDN, you can use Mininet. Battery is included. OpenFlow protocol, OpenVSwitch, software switch, POX, Wireshark dissector, yeah. And it is built using Python, also utilizing several technologies. And it is also you can run it in command line, and also you can write Python code and try to use the Python IP. So the command is just sudo mn, and you can have one controller, one switch, and 2 hosts, just like that. Yeah. So 3 basic steps. The easy one: download the Mininet virtual machine and boot the VM with VirtualBox and sudo mn. So we have the Mininet. I'd like to do some demo here. the time is, I don't know if the time is. I have this virtual machine with Mininet. You can download it on the mininet.org. I just SSH the virtual machine, and I just need sudo mn. And it builds the network with 2 hosts and 1 switch. It is like this. Type on the image, and we can you can type command here to interact with Mininet nodes. We have controller 1, controller 0, host 1, host 2, switch 1, DOM. If we want to see the information of the host and the open fish switch, we also can have do some thing. I also I run simple HTTP server here in host 1, and I can access from host 2 to we get the page from the host 1. I can also kill the Python to stop the simple HTTP server. And I also can use and show the extern H1, H2, or S1. And you can interact with the each host to try something, ping or PC breakdown or anything. And in Mininet we have also regression tests. We have you can run this command and to test to create the topology single with 3 hosts and try to ping all. And you can try anything, changing topology, link variation. You can set the bandwidth. To build some custom topology, you can try to write the some source code in Python using the Python API from the Mininet. It is easier to read. Just self-add host, self-add link, and try to load in sudo daemon, custom topo, yeah, and then anything up. And you can also running the interpreter Python. You can run py h1.ip. It will show the IP address of h1, link up, link down, and anything. You can see in the Mininet examples we have packages that have Py source code in there. I just want to skip fast because the time is limited. The SDN apps. We have application that build built-in box to we can see here it is an application on the top of box to discover the switches and the internet, the interconnected links between switches. It is in Python. And there is two projects that I will mention here. The first one is the throat flow. It is some SDN controller applications. The topology, the architecture is there in front of you. You have the programmable switch here, the open flow. We have the legacy network here, and there is virtual networks on the top of the SDN. So throat flow try to migrate, to try to give some way or alternative way to migrate from legacy IP deployment to SDN. And you can just put your configuration from the IP networks to the SDN by putting the configuration on the top of the applications that build with virtual networks. The SDN Controllers box and RIU, or you can choose one. This is the architecture, the data path, controllers, and the second one, Faucet. It is based on RIU. It is targeted for enterprise networks. So we have this plane, and if we have the Python-based controller, we have Python application. So the Python can be used to define networking. And if we see that the lightweight feature and easy to moderate learning curve makes Python interesting to be learned and developed, and controller, if we have the controller that based on Python, we can write network application based on Python, and that's all for me. Thank you for your attention. Let's give applause to Setiawan from the University. Thank you very much, Mr. Iwan.